Hi everyone. Today we're going through the Log4J2 features. Before we start, let's go through some history of the Log4J. Log4J1 is coming out around 2001. Along the way, it a new feature adding in, and also there has some because of some shortcoming of the Log4J1. We see some new framework coming out, the SLF4J, and also the logback coming in. So those frameworks try to address Log4j1's so-called the shortfall. So in year 2012, the Apache Log4j team decided to say they start a new implementation version 2, Log4j2, by taking in all the new feature that introduced by the SLF4j and also the logback. Okay, now we go into the topic. This topic, we will not go through all the detail, but we will only highlight those special features that Log4j2 introduced that different from others. Okay, so the first thing is that inside the Log4j2, they decide to separate in their implementation into two parts. So they call API separation. So the API portion, they have one layer called abstract API layer, which is similar to the SLF4J. So that the code you code using Log4j2 API, in future, you can changing the implementation part by plugging in different logging mechanism. Then there's another part it's called the core portion, which is the actual logging implementation. Later we'll come into the slide to the screen. So the second interesting thing is that they are introducing a new async logger, which is using a next generation logging mechanism. Behind the implementation is really they're using a third-party library called LMAX disruptor, which is a high-performance inter-thread messaging library. This one will improve quite a lot in the multi-thread environment logging. The third one is the random access file appender. This has a better performance compared with the traditional file appender because they're using a random file access, which will have a better performance in multi-thread environment. Because now a lot of things we go into multi-thread. Later I will show some diagram. Okay, now we go into the API separation. So in the API separation, you see the green box. Now the Log4j2, they separate into the API, which is only for the coder, that means the Java coder will using the syntax, Log4j2 API syntax. And behind the scene, they have another implementation is Log4j2 call. This part will decide how the logger will call log, how they append the logging message out. And by separating these two, they support the mixing of different implementation combination. So which means that in future, now if you're using SL4J API, we can use a bridge to bridge the code. And behind the scene, we can use the Log4j2 call appender, like async logger and appender thing. Without changing your code, just by configuration, you can just switch your code to use the Log4j2 implementations. So by separating, this is the advantage of separating the API. So even that, now let's say we start coding using Log4j2 API, we can wire it to a so-called logback implementation by using bridge. I didn't show the bridging between the Log4j2 API to the logback core implementations.
So I think the main feature behind of the API separation, what does means? The Log4j has the API and core. So just you implement the code, you can use any Log4j. You can use SL4j, common log, logback. You can use anything. Just you copy the Log4j bridge to your project. The project automatically convert to the Log4j. So that means you don't need to do any code change to get all the Log4j2 feature. So that is a very unique feature they did very first time. So you can have whatever you have the framework. Just copy the bridge jar file or the library to your project. Once you restart the project, once you recompile the entire project, restart the project, that project is capable for the Log4j2. So we will go through the latest, right? What is Log4j2 unique features, but this is one of the key thing they did it It's a plugin architecture. You don't need to do anything. Just copy their work file. Immediately, the entire all the implementation has been overwritten by Log4J2. So that is a API separation. It's very unique. Only few people do it in the.
Actually, they want to achieve that without your code change, you can enjoy the Log4J2 core implementation features by some configurations and jar file.
Yes.
So that's what they try to achieve by API separation.
So this is something very good candidate who using the Log4J1 command for a very long time. Without doing any code change, they can able to do it to migrate to Log4J2.
So the bridge, would it provide all the new features of Log4J2?
Yes.
Or it will expose only the one feature?
Because the core portion actually is designed on the logging, how the logger accept the logging message, and how they log the detail into file or other like DB, all those things.
So I think the question is, yes, it will accept all the feature. It will give the more feature also. Like a Log4j, you have only few log appender. If you put the bridge also, it will improve the performance as well as it will bring the new features also.
Maybe for example that we go to the last slide. So you see that Log4J1, they only have few appender that's supported. By switching to using the bridge, and we use the Log4J2 core, we have more option to how we're going to log the details. We have a GPA, we have a non-SQL DB. All these are new that introduced into Log4J2. So without changing the Log4J1 code, but the way how we log, we can switch to use the Log4J2's implementations.
So if you see the file column, then there's so many file appender, random access file handler, rolling file appender, memory mapped file appender. There's a lot of option you have it, and moreover it will bring all the features like a log, SL4J, logback, all the appenders are also there. So
later we will come across the random access file appenders. This is new inside the Log4J2. So if we switch over using the bridge and the Log4J2 core, we can use utilizing of the random access file, which give a lot of improvement in the performance wise. So we go back. Okay. So this is what Log4j API expression about. That means they're separating the coding part, the API part, and the actual implementation, which is the configuration part. Okay. So now the second thing that they're introducing the async logger. This one they're using the disruptor where they will have a lot of improvement inside the multi-thread environment. So we see from the chart, the blue and the red are actually using the async logger, and you see that the message per second output, that means every time how many message log is increased when the thread going up.
So can you point over the mouse? You can see everybody can see which is the one. They use the mouse, can point over.
You can see that this is a Log4j2 using the async logger, and this is mixing of the async and the normal sync logger. So you see that after more than 2 threads, these two configurations are logging more compared with the conventional one. As for Log4j1, which is in purple color, even we increase the threads, actually the number of message logging up per second actually go down, because they need to some communication to sync between multi-thread. So we can see that if we go into multi-thread, I mean more threads, the async logger will perform much better compared with the existing convention Log4j1 and also logback. Okay, this is the throughput. This is a message per second. Yeah.
So here you can see as the thread count increases, the number of messages per second is increasing, right?
Yeah.
So when I'm calling Log4j2, who manages the thread? Since it's asynchronous, it's just as long as the the threads are available with Log4j creates a thread, or as a developer, I need to make more threads available for Log4j. So who's responsible to increasing these thread count?
There's some configuration there, which is underlying the disruptor layers. There's some configuration that they can configure the pool part. And also the disruptors using a different technology. They are using something called multicast messaging, which is different with the traditional queuing way of handling. That's why in multi-thread environment, they can make sure that the turnaround time for the call logging is consistent. Later, the next slide will show that the turnaround time, I mean the latency time for calling a log.
So I think the thread configuration you have based on your hardware, the developers has to be configured. What is my thread threshold? So that is the question, right? So in order to get the, for example, right, the performance is good for 64 thread. So the question is how we can configure the 64 thread. So where to configure the 64 thread?
No, this is application thread, right? The number of application thread accessing the log at any point of time, right? 64.
Actually, inside the disruptor configuration, you also have some configuration that you can configure.
In the Log4j2, you have to configure to support 64 thread.
Inside the
so Log4j will be running in 64 threads, right?
Even that we can run a lot of threads, but there's some disruptor configuration that we can set how many pool that we're going to handle.
Okay. So this 64 represents the application thread or the configuration pool you're talking about?
It's not I think it's a log thread.
Log thread.
Log thread.
So log thread means it's your application thread.
Application corresponds to the application thread, right?
Yes, yeah. It's application thread.
Because your application only accessing the log, like logged up error or whatever it is.
It's not the native thread of the OS. There's one more layer and the kernel thread. Not those.
So I think when logs start there, right, the log manager itself, they have their own thread management. For example, internally, that's our understanding. Like if we put log.error, then the log manager will create the new thread, right?
No, the get logger.
Okay, get logger will create a new thread. So, but
yeah, I think it's a Log4j thread.
Yes.
Like Ramesh saying, if it's configured to use 64 thread, as a developer, you don't need to worry. You just call Log4j. That's it.
Yes.
Right?
But
and internally, it will, based on the configuration, it will start 64 threads or whatever thread you configured. Maybe that's how it's doing.
Yeah. So, but the underneath is you have the hardware need to be there. Like for example, they put here you need 16 virtual core to the hardware should be capability to able to span that much of thread. That is the most important.
Because when you do a benchmark, you have specified the hardware testing condition. Yeah. So as a benchmark, you know what you test.
It also depends on how much memory CPU each thread is using, right?
Yeah, correct.
If you put simple Amazon small Amazon VM, then put 64 thread cannot. It's a backfire your implementation. So you should know what is your hardware limitation, whether the hardware can support this much of core thread. That is the most important. And you need to calculate it. This calculation is very tough. You need to calculate how much your log, how much your application, what is your core, what is the CPU memory. You have to put that performance calculation. So there is some of the tool there, so you can use that tool to configure it.
So actually, what they try to explain is that in multi-thread environments, the async logger is perform better compared with the traditional one.
So that means the objective is if your application is you want to have spam more thread, your hardware is good, let's go for Log4j2. Use simple application, simple website, simple application, don't go for it. So that is the main content you want to
still
convey.
At any point of time it beats the other threading.
Yeah.
Even single thread also I think it's still better than
better.
But 64 thread is good for worth to go for it. I won't say 8 thread is same time 4,000, 6,000. So it's not much difference.
mean, you can see the significant difference when the number of threads go up.
Thread
Yeah.
goes up.
See, if you go 64, it's a spike like from 8,000 to 18,000. It's
I think
really.
the intention is like they are saying at any point of time, if the load grows, we are still able to high, and the performance will increase rather than decrease. That's the
Yes.
intention of showing this.
You're putting in more worker, you're getting the equivalent output.
Yeah.
So you put the more load on the system, it perform better.
Okay. So then we go to the next slide. This is the maximum latency time. That means when the programs they call log, how long the logger will take to respond. Let's say I complete the log. So you can see that when the thread go up, is it the time that for the logger to respond, say I have already processed your logging request, is quite consistent. They don't become longer. As you see, the traditional one is it when the thread go up, it take longer to respond. So I mean this is also why the reason that in multi-thread conditions I can log more things because I put in the same more worker. Actually, each of them is performing the same efficiency. Then the output will go up.
Yes. So traditionally, what happened today? You have a lot of login. If a system have the more requests, people say we are logging too much. Can you disable my logging to get the better performance for the many user? So one is the middleware. We say the middleware whenever the release date come, right, everybody access it. We see the so many log. So log is occupying lot of your time. So what happened if you have the more load? If you have SL4J, then even the one thread or 64 thread is the same latency. So that is the main thing. Like even you serve one thread, it will take 10,000 nanosecond. Then if you serve the 64 thread, it will also 10,000 nanosecond. That means you even get you have the more load, you get the same performance even as 1% or 100%. So that is the main latency is very important because today the challenge is people will all complaining it. Hey, I have so much of logging. The logging itself takes a lot of time to write not completion. I think the fire and end of the completion takes a lot of time. Like one request takes 10 nanosecond. Then if everybody accessing it, it will really killing the system. So if you Log4j is a very good candidate. If you identified your application slowness based on the Log4j, it's a very good candidate. You can move it to Log4J2 without changing your code, just put the build bridge. So here the proof JDK 1.7. Of course, JDK you need JDK 1.7.
No, actually the minimum requirement is 1.6 only.
Oh, 1.6.
So that means even UPTC we can use it.
But the benchmark they saying 1.7.
Yeah.
I don't know 1.6 have a benchmark.
Yeah, that one you have to do the benchmark because it's different testing conditions. Okay, so that's for the async logger. Now we go to the logging to the file. Just now async logger is accepting the log request. The appender is how we process the log message to the physical target. So now they are introducing a new appender called random access file appender. In Log4j1, they only have something called file appender, which is using I think they're using the byte output stream way of piping out the message to the actual physical file. But now in the Log4j2, the random access file, they are using random access file plus a byte array. I think. So you see that the throughput for messages per second, I mean how many messages per second they can log into the file is actually much more better than the file appenders. So you see the blue color is the random file access file appender. The green color is a rolling random access file appender. The difference is a rolling random file access appender is like when you reach certain size, you create a new file. I mean, it's like what we do now is log 1, log 2, log 3 like that. You keep fixed size, you move to the next log file.
Every 500 megabytes, you throw to a new file and back up the old file.
So we are using the file appender?
No, we are using rolling file.
Or rolling file appender. Okay.
So that you keep the file size not too large. Going. So we can see that for the thread, is it the number of thread go up? Is it the convention way is their performance is almost stagnant, not much improvement on that. As we're using a random file access file appender, it's really you can log more. I mean it's consistent with number of worker or thread you put it in. So this is the new feature that introduced by Log4J2. Okay. So the last slide is just showing that in Log4J2 they're introducing new appender for newer technology like NoSQLDB, JPA, random access file appender.
What is NoSQL appender?
I mean they can append the auto message to NoSQLDB.
NoSQL, Hadoop and those NoSQL.
I mean they saw the login message to SQL.
Oh, good.
Because last time we have a JDBC appender.
Yeah.
They log to the JDBC type of DB. And
JPA?
JPA, I think they log into JPA way.
Oh.
They go through a JPA.
Very good.
Login to database using JPA.
Oh, good.
So there's actually one more that quite new is it's Apache distributed collecting the logging message server.
Oh, yeah.
So they can log to the server, then the server is.
I think nowadays they have the log server. So all application they instead of writing to the file, they have log server. So log server they are appending it. This is the commercial by Westpierre. So it's a free.
The only people who write to a file is us. Nobody writes to a file these days.
Yeah. Of course, this is a 2007 project. So 2007, there's no such a call file server. So we'll stop recording, then we can get the Q&A. So the Flume appender,
you must work with the film server, the Apache film server.
This is done. So we start this Q&A.
Say thanks.
Yeah, thank you. That's for recording. So we stop recording.